All right, in this video, I'm going to talk about the quadrants on the coordinate plane, and this is a unit circle that I've drawn here, and we're going to talk about the trig functions and whether they are positive or negative for angles that terminate in different quadrants. So if the angle terminates in the first quadrant, we're talking about a point, it's going to terminate at it's going to have a terminal point right there in the first quadrant, and for that point, no matter where it is, it's going to have a positive x coordinate and a positive y coordinate. So in this case, we would have cosine of the angle would be positive, and sine of the angle would also be positive. Furthermore, since the ray, which comes out of the circle there, the ray coming from the center, since that is going to have a positive slope there, the tangent function of that angle will also be positive. So in the first quadrant, all three of those trig functions, of the basic three, okay, the main three, sine, cosine, and tangent, all three of them are positive. In the second quadrant over here, if you have a point in the second quadrant, because it's to the left of the y-axis, the x-coordinate is negative, but it's still above the x-axis, so its y-coordinate is positive. And this ray coming out here, because it's from left to right, it's going to be sloping downwards, it's going to have a negative slope, right? So in this case, cosine of t is going to be negative. Okay, looking at the negative x-coordinate there, cosine will be negative. Sine of that angle will be positive, and tangent will also be negative. So the only one of those three main trig functions which is positive is the sine. I'm going to highlight the ones that are positive here. Okay, third quadrant. If you take an example point in the third quadrant, let's take one down here. X is negative because we're to the left of the y-axis. Now we're beneath the x-axis, so y is also negative, but the slope of that line from left to right that's sloping up. It's a positive slope. So here in the third quadrant for an angle, sine of t is negative, cosine of t is negative, but tangent of t is positive. So of the three, the only one that's positive is tangent. And then finally, you can fill this in probably. Let's take one over here. A point in the fourth quadrant. Let's take this point over here. That's going to have a positive x, a negative y, and this slope sloping downwards, it's going to be negative. So we'll have cosine is going to be positive, sine is going to be negative, and tangent is going to be negative. And the only one of those which is positive is cosine. So there is a mnemonic to remember of the three most common trig functions, sine, cosine, tangent. If you want to remember which of those functions are positive in each quadrant, going in order 1, 2, 3, 4, we can use the letters A for all three of them, okay? S for sine, T for tangent, and C for cosine. A, S, T, C, going in order 1, 2, 3, 4. Those letters represent the which of the main three trig functions is positive in that quadrant, okay? Like for angles terminating in that quadrant. There's a mnemonic for this. All students take calculus. Obviously, this mnemonic is a little bit better for calculus students. You folks who are pre-calculus students, I imagine many of you are going to go take calculus. It doesn't matter if it's true or not. It's a mnemonic, right? ASTC, all students take calculus. If you remember that, it just helps you because it's useful to know if trig functions are going to be positive or negative when they're in different quadrants. Okay, we're gonna take that idea. That idea is going to help us. What this essentially means is if we can sort of relate an angle back to some sort of equivalent, not exactly equivalent, I want to put big air quotes on that, but basically we're going to take an angle. I'll draw you a picture. Take an angle anywhere on the circle. Let's say it's like over here. If you bounce it across axes, like reflect it across the axes, I'd like to think of it sort of bouncing back over towards the first quadrant. What's going to happen is you're going to get back to a point in the first quadrant that's going to have not the exact same x and y coordinates, but maybe opposite signs, right? So like if this point is x comma y, then this point down here, since it's reflected across the x-axis, the x coordinate is going to be the same. The y coordinate is going to be opposite, negative y. And this point over here, reflected across the y-axis, and it's going to have the opposite x coordinate, but the y coordinate would be the same as this one. So that's negative x, negative y. And then you can also bounce up to here, this point here on the unit circle. It's a reflection across the x-axis from this one, and it's a reflection across the y-axis from this one. So here the x coordinate is going to be opposite, but the y coordinate is going to be the same. Okay? So the idea of a reference angle is like take a point anywhere on the circle and refer back to a reflection of that point back over in the first quadrant. That's your reference angle. If you can find a reference angle, then you can figure out what the sine and cosine value of that reference angle is. And then all you need to do is make an adjustment to the sine to put it back into the correct quadrant, right? Like if you need to adjust the sine, either adjust the cosine value or the sine value, right? Adjust it to be negative according to which quadrant it's in. And for that, you can use all students take calculus as a mnemonic to remember what the signs are, right? Whether they're positive or negative in which quadrant. So I'm going to show you an example of this in a second here. But I want to say basically there's a rule for finding reference angles. So to find a reference angle, basically what you're going to do, besides just, you can do it geometrically and sort of using some spatial reasoning pretty easily for a lot of angles. And so I'm going to show you the sort of intuitive spatial reasoning, draw pictures kind of approach. But I also want you to know that you can do it more analytically by basically taking different multiples of pi, integer multiples of pi, and either adding or subtracting the angle you're looking for. And you try different multiples of pi, for k in a set of integers here, until you get a number in 0 to pi over 2, which would be the first quadrant, 0 to pi over 2. And I presented this idea in terms of radians, but you could do the same kind of idea with degrees as well. So essentially you're taking, a lot of times you take pi plus the angle or pi minus the angle and see if one of those is in the right quadrant, back in quadrant 1. And if that didn't work, you try 2 pi plus the angle or 2 pi minus the angle or other multiples of pi plus or minus the angle until you get something that works that's back in the first quadrant. All right, so in the next video I'm going to do an example.